All right. So today we're going to talk about circles. We're going to talk about something really cool. It's called the point of tangency. Now, tangents with circles, it's just the same word, but it's not the same thing. It's not like opposite over adjacent in a triangle. It means something completely different. We're not comparing anything with this tangency. This tangency basically says if I take a line and I put it on a circle, but I only cross the circle in exactly one point, then we're going to call that point the point of tangency. Okay, so the definition of a line tangent to a circle is it touches the circle in only one point. So basically you could have a line that doesn't touch a circle, you could have a line that touches the circle in exactly one point, or you could have a line that touches the circle in 2 points. Could you ever have a line that touches the circle in 3 points?
No, because then it wouldn't be a line.
Yeah, then it would have to like turn around and curve or something to be able to do that. And once it starts curving, it's not a line anymore. All right, so if we have a line that's tangent to the circle, if we start out knowing that we have a line that's tangent to a circle, then it's guaranteed 100% that that circle's radius and that line will be perpendicular to each other. First theorem, very, very important that you know this. If you have a line that is tangent to a circle, then it's perpendicular to the radius. And we're going to see a lot of applications of that as we move through this section.
Do we start putting triangles with the radius and then the tangent line?
Sure, why not? All right, so we'll start out with this picture right here.
Oh no, I knew it.
Okay, in this picture right here, we are given that point M forms the line ML, and ML is tangent to the circle. We're also given that MN is tangent to the circle. By the way, this section had proofs in it, but I didn't give you any. You're welcome.
Don't go.
You're welcome. I was thinking about you over the holiday. All right, so now that we know that the two lines are tangent, what can we say about angle L?
It's 90 degrees.
It is 90 degrees because if you have a tangent line and a radius, they will be perpendicular. What about angle N? Same. So we can find the missing value of x because notice LMNO forms a four-sided polygon. So if we go back to the angle interior angle sum, and the interior angle sum is equal to n minus 2 times 180. I believe that's how you find the interior angle sum. So the interior angle sum is going to equal, in this case, 4 minus 2 times 180, which would be 360. And then if I want to find the missing angle, it's just going to be 90 plus 117 plus 90 plus the unknown angle x is equal to 360. That means x plus 297 is equal to 360. And so x is going to be equal to 63. So that's choice what?
B.
B. So I would bubble in choice B for my answer. Everybody okay with that? I used something that we learned earlier in this year to find out what the sum of all the angles are. I created an equation putting in what I didn't know, putting in everything that I did know. I solved, and I found out what I didn't know. It's a discovery. Yes, ma'am?
What was the theorem you said we had memorized if you had a line tangent to a circle?
If the line is tangent to the circle, it's going to be perpendicular to the radius. That's how I knew to put the 90 degree here and the 90 degree here. Does that make sense? All right. So I tell you what, you and your partner work on this. Maddie, I guess you can.
I'll go solo.
You want to just go solo? All right. So I feel at this point, if I ask either you or your partner what the correct answer is, whichever one I ask the answer for, whatever they give me, I can grade both of you on. So if I were going to do daily grade spot checks and just be like, hey, what did you get for this one, Alex? And whatever Alex says, that counts the answer for Alex and Eli. So you need to make sure you're talking with your partner. So let's see those pencils moving. All right, see if you can't do this. Find the value of x. Same concept, different shape. All right, so the correct answer is 52. We know a triangle is 180. We know that's 90. So 90 plus 38 subtracted from 180 gives us 52. Does anybody need any further explanation on that? All right, on we go. Now let's do a real-world application. Oh my gosh, I'm traveling to Toronto, Canada, and I'm going to go to the top of the CN Tower, which is 447 meters above the ground. Oh, that's bad. I'm very much afraid of heights. And about how far is it from the all right, so we know that if we look at the horizon, now this is something really cool that you probably didn't know. If you look at the horizon is actually where the sky and the ground meet. And that's technically a line that's tangent to our very own planet Earth.
You're right.
I am right. So what we're going to do is we're going to use the concept of the horizon line as a leg of a right triangle. The reason we know we're dealing with the right triangle is because we're going from the center of the Earth to the edge of the Earth, that's the radius, and a point of tangency, which is the horizon. And radii and tangents are always perpendicular. So that gives us a right triangle. By the way, how in the world do you think we found the radius of the Earth? What crazy cat came up with that, and how do we know he's right?
Cat?
Meow.
I have no idea.
Think about some ways that you could find radius. Think about some formulas that involve radius.
Pi d. Or
Pi r squared. So if we found the area of the Earth, which we could do but would probably be extensively painful. And technically, I think we would need to know the radius of the Earth to find its area. What else could we find? What other formula do you see R crop up in? Starts with a C.
Circumference.
Circumference. Do you think we could travel all the way around the world and find out the distance all the way around the world?
Yeah. Sure.
We probably can do that. So if you go all the way around the world, you have the circumference of the planet. Make sure that you go over the poles when you do that. And if you have the circumference of the planet, if you divide that by 2 pi, you get the radius, because C equal 2 pi r. So if you know C and divide both sides by 2 pi, you're left with r. So we can find the radius of the planet. I know that's incredibly exciting to you. Let me tell you, it's a whole lot better than drilling to the center of the Earth, because you would catch fire and explode. So we know the radius is about 6,400 kilometers, and the radius is going to be the same in both places. So the hypotenuse of this right triangle is actually a little bit longer than this leg, because this is 6,400 kilometers, and then this is 6,400 kilometers plus 0.45 kilometers, because we know how tall the structure is. And we round it off to the nearest hundredth of a kilometer. By the way, this is not drawn to scale. All right, so since we know that this is a 90-degree angle, what type of triangle do we have?
90.
What kind of triangle is it? Well, we don't know it's a 30, 60, 90, but we do know it's a 90, which means it's what type? It's a right triangle. And what really cool formula do we have that goes with a right triangle?
Oh, the Pythagorean theorem.
You got it, the Pythagorean theorem. Your friend and my friend, old a squared plus b squared equals c squared. And in this case, a squared plus b squared equals c squared means the horizon line squared. So I'm going to do HL squared plus the radius, which was 6,400 squared, is equal to the hypotenuse. The hypotenuse was the radius plus the height of the tower. So that's 6,400.45. Just a little bit further than 6,400. And I'm going to make this a capital H. HL stands for horizon line. Everybody okay with that? So how do you think we're going to solve for horizon line? Shelby? What are we going to subtract? Yeah, let's do all the math and the setup, and then we'll put it in the calculator. So if I wanted to subtract before I would square it, what would I subtract? 6,400 squared, right? So if I've got 6,400 squared on one side, and I subtract 6,400 squared from both sides, I end up with something looking like this, right? And then, if I wanted to do all of my mathy stuff before I put it in the calculator, that's a horrible, horrible hypotenuse line. If I wanted to do all my mathy stuff before I put it in the calculator, I could just put this in the calculator, couldn't I? The square root of 6,400.45 squared minus 6,400 squared. Let's do that. Let's put that in the calculator. So I'll take the square root of 6400.45 squared minus 6400 squared. And when I do that, I end up getting 75.89. I think I'll round it off to 76 kilometers. So the horizon line is 76 kilometers away. The ground and the sky meet 76 kilometers away from where I am. How did I find that? Just knowing stuff about circles and triangles. Pretty amazing. By the way, could you ever just like run a tape measure? Could you tie a string on yourself, jump off the tower, and run to the horizon? No, because number one, after you fell 447 meters, you would die. But even beyond that, if you run towards the horizon keeps moving away from you. All right. So that's how you would find the length of the horizon. So here, you do one. What is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above the Earth? By the way, the Earth's radius is about 4,000 miles. So 6,400 kilometers, 4,000 miles is about the same thing. I think what I'll do for you guys is I will go ahead and like draw a picture for you. Because sometimes it's good to draw something. So there's the center of the Earth. I will represent the Earth by something we like to call a circle in these parts. And I will represent the airplane by drawing an airplane. That's not going to be an airplane. Let's draw an airplane like this. All right. By the way, this is not to scale. So when you connect the airplane and the center of the Earth, and you find the horizon to the airplane, that horizon line's a little bit high there. Then you know that the radius of the Earth is 4,000, and then the airplane is 2. Once again, my drawing, not so much to scale. But you should be able to find the length of the horizon. So y'all go ahead and work that out real quick. All right, so hopefully you got this worked out. I used the Pythagorean theorem, plugged in x and 4,000 as legs, 4,002 is the hypotenuse, solved for x. I got 126.5, which I'm going to round off to 127 miles. Everybody okay with that? Yes, ma'am.
Can you show me, or like show on the screen how to type that into the calculator, because mine keeps saying don't use it.
Okay, what I do, are you using a scientific calculator? Okay, what I do is I go ahead and type the square root, and then I do 4002 squared minus 4000 squared, and then hit enter. Are you doing the square root? I'll have to look at your calculator. We'll have to troubleshoot that if we have time at the end of class. All right. Or the next time I give everybody a problem to work on, you can bring it up here and I can show you. All right. So we can also deal with the converse. The converse says if you know that the two lines are perpendicular, then you're dealing with a tangent. All right. How is this useful? Well, in this particular situation right here, since this line is perpendicular, we can use the Pythagorean theorem to fill out missing values. So this is going to be a little bit different than anything we've done before because we're going to have to dig back into our Algebra 1 storehouse of knowledge and remember how to square a binomial. Because remember, the Pythagorean theorem is a squared plus b squared equals c squared. And a squared, one of the legs is x. B squared, the other leg is 12. But what's the hypotenuse? Yeah, it's x plus 8 squared. And I'll go ahead and tell you right now that x plus 8 squared does not equal x squared plus 64. I know that makes you mad because you're thinking, well, why not? Well, if I took x plus 8 times x plus 8 and I foiled it, first, outer, inner, last. It's actually equal to x squared plus 16x plus 64. If you have a squared term, when you square a binomial, you're going to end up with 3 terms in your answer. If this were to the third power, you would end up with 4 terms. And in Algebra 2 Trig, you'll learn how to cube a binomial. You'll learn how to raise a binomial to the 4th power. You'll learn the formula for raising the binomial to the 10th power, or even the 100th power. If you raise a binomial to the 100th power, you have 101 terms in your answer. We only have to worry about squaring a binomial, though. And the way you square it is you square the first term, you square the last term, and then and this is always a plus. And then in between is this sign, and these two numbers multiplied together, multiplied by 2. So 8 times x times 2 is 16x. And that should be a plus. So that's how you square a binomial. Square the first term, square the last term, multiply the two together, and double for your middle term. You remember that? Y'all not going to talk to me anymore? You mad at me? All right, so x squared plus 144. All right, what happens when I subtract x squared from both sides in this equation?
It cancels.
Right, they cancel each other out. Okay, and then I'm left with 144 is equal to 16x plus 64. And that's going to leave me with 80 is equal to 16x. And so x will equal 5. So the radius of that circle is 5 to finish answering my question. So once again, Pythagorean theorem, very useful. But we also reached into our little Algebra 1 tool bag and squared a binomial. 2 very, very cool things that are ACT test appropriate questions. All right, we're ready to try it on our own? Or do we need to talk about it some more first?
Let's try it.
All right, let's do it. Here you go. Stephanie, if you want to come back here and let me take a look at your calculator. All right, so hopefully you were able to work this out. I used the Pythagorean theorem. I plugged everything in. Remember, when you square the binomial, it's x squared plus 12x plus 36. You got to multiply these two together, multiply by 2 to get the middle term. The x squareds will cancel on both sides. That doesn't always happen. If you still are left with your x squared term, you might have to factor. You might have to go to the quadratic formula, but you know how to do that. Here we got lucky and it canceled out. And then I was left with 100 is equal to 12x plus 36. Subtracted 36 from both sides. 64 equal 12x, so that's 64 twelfths, which reduces to 16 thirds. Remember, if you want an exact answer, you need to leave it as 16 thirds and not 5.3, which is how bad people do it. All right. The other thing we can do is we can decide if a line is tangent or not in certain cases. So here, I've given you all the sides of a triangle, and you just have to decide if that triangle is a right triangle. If that triangle is a right triangle and this is a right angle right here, then we know that this is the tangent line. Because if you're right angle to a radius and a line, then you have to be at the point of tangency. How am I going to do that? Well, I'm going to check and see if 7 squared plus 24 squared actually equals, and I don't know if it equals or not, but if it equals 25 squared. Well, that's 49 plus 576. 625, and when you add these two together, sure enough, 625 does equal 625. That checks, so yes, we are tangent.
That's not the
Does that make sense? All right, you do one. Decide, yeah, I know. Decide if, I'm going to use the same figure right here. But we're going to put in different numbers. So if you read the problem, whoa. If you read the problem, then that 7 becomes a 4. That 24 becomes a 7. And the 25 gets an 8. So decide if 4, 7, and 8 form a point of tangency. Remember, when you hear point of tangency, what kind of angle should you be thinking, Maddie?
Right.
Right. Correct. All right, so if you go through here, you'll see that 4 squared plus 7 squared ends up being 65. 8 squared is 64. So the two are not equal to each other. So that means, nope, we're not tangent. This was not a right triangle. This was not a right angle. This is not a point of tangency. Make sense?
Yeah.
All right. Last thing I'm going to talk to you about. If you have a point outside a circle and you draw the two tangent lines that you can draw, those two segments will be congruent. So if BA and BC both form tangent lines, then BA and BC will be congruent to each other. So that lets us do some really cool stuff like this. I can actually find the perimeter of this triangle by knowing that all of these lines are tangent. Now, how do I know all of these lines are tangent? Because I told you that the circle was inscribed inside the triangle. And the definition of inscribed is, I use the center of that figure, and I draw a circle inside the figure that's at the point of tangency. So if you remember way back when we were doing in-center and orthocenter and all of that stuff, we were able to find certain types of lines and points inside a triangle. And so if the center of the triangle can be found, which it can, then you can draw a circle that's inscribed inside the figure. Inscribed means the circle will touch the edges of the polygon at a point of tangency. So anytime you see the word inscribed, you're talking about a bunch of points of tangency. So this is a point of tangency, this is a point of tangency right here, and this is a point. In fact, that's so important, I think I'm going to put it in red. Point of tangency, point of tangency, point of tangency. Now, if I know that all of those are points of tangency, that means that this length right here and this length right here are the same or congruent. And so if this is 10, what's AF going to be? 10. And if this is 8, what's CE going to be? 8. And if this is 15, what's BE going to be? So now, can I find all the side lengths of the triangle? Yep, this one would be 18. This one would be 25. And then this one would be 23. So I now know all the sides of the triangle, so can I find the perimeter?
Mm-hmm.
Sure. 18 plus 23 plus 25 is going to equal the perimeter, because you just add up all the sides. So that's 41, 66. The perimeter is 66. Yep. So knowing the perimeter formula and being able to fill in the things that I didn't know, there was no variable to solve for other than perimeter. So Once again, I set up an equation, I plug in everything that I do know, and I solve it for what I don't know. So this practice problem I'm going to give you on this technique is a little bit different because I'm going to change up where I put the information. So what I want you to do is I want you to now, knowing that the perimeter is 88, I want you to find the value of QY. So see if you can figure out what QY is, knowing that this information here and perimeter. I'll give you a hint. If I were to find the perimeter, I would want to know side 1 plus side 2 plus side 3 equal to perimeter. So I would use that setup. And then see if I can't fill out as much as I can about the sides. I go with writing in what I know. So I know that PZ is going to be equal to 15 because PX was 15. So 15 here, and then I know that I've got a 17 here. Oh, cool, I can go ahead and get this side. This side's 32. The problem is I have no clues to what these two are. But I know that if one of them is X, the other one is going to be X because they're congruent. So I now have links for all the segments. I could say that this side is 15 plus X. I could say that this side over here is X plus 17. And I now have all three sides labeled. So side 1 we'll call 32. Side 2 we'll call 15 plus X. Side 3 we'll call X plus 17. And perimeter we'll call 88 because it told me at the top it was 88. So there's my equation, and I'm down to one variable, which I love because anytime you have an equation with just one variable, you can always solve. So 32 plus 15 plus 17 is 64. X plus X is 2X. Everybody with me? And then subtract 64 from both sides, and we get 2X is equal to 24. And divide both sides by 2, and we get X is equal to 12. So that's your solution. What did you do?
Okay, so I knew that both sides were congruent, so I added 15 and 15 and 17 and 17. My equation was 30 plus 34 plus X equals 88. And I got that to 88 minus 64, and I got this side is equal to 24, and I just halved it because I knew that.
That's fine. So you basically did that. So your X was both of these,
Yeah.
and you knew they were the same, so you just halved it when you're done. Your logic is impeccable. And that's really all I care about is that you can logic through these. You don't have to do them exactly like I do. But I want to teach you thinking skills so that you can solve things logically. That's exactly what we're learning here. So Mr. Baker, very proud. You get a star. All right. There's your homework.
Was there any fun events at the hospital, Mr. Baker?